Hello, friends. Welcome to my home, the mysterious and beautiful random forest, where all creatures live in harmony and any outcome is equally possible. Right now, our friend Ms. Cherry is trying her luck at the Random Forest Casino. She's not doing so well, though. She just lost for the 9th time in a row. She knows that she has a 1 in 5 chance of winning. Miss Cherry says to herself that surely that means she's certain to roll 7 or 11 this time, right? Nope. Here we are at home in the peaceful shade of Random Forest. We watch some of our friends walking along on their way to a picnic lunch, passing under a big old oak tree. Oh no! Mr. Barry got hit on the head by an acorn. Poor little guy. Now, I'm curious, how dangerous is that oak tree? What's the chance that if I walk under the oak tree, I'll be hit with an acorn? So I sit and observe. In one day, 300 of our friends walk under the tree, and 3 of them get hit by acorns. Probability can be found by taking the number of times a certain outcome occurs, like getting hit with an acorn, and dividing it by the total number of events in which that outcome might happen, so walking under the tree. This is called experimental probability, where we calculate it based on what actually happened. In this case, 3 people getting hit by acorns. Another type of probability is called theoretical probability, which is more like what Ms. Cherry is dealing with at the casino. Theoretical probability is what should happen, given the number and likelihood of all possible outcomes. Theoretically, she should win 1 time in 5, but that might not be what actually happens. Hopefully, we'll get to talk more about the different types of probability and maybe related words like likelihood or odds in a later video. So to calculate experimental probability based on our day of observation, we take 3, the number of times someone was hit by an acorn, divided by 300, the total number of times someone walked under the tree, and we get 1%, or 1 out of 100. But here's the tricky bit. We just did that calculation and came up with our probability of 1 out of 100 based on our day of observation. Does that mean if I walk under the tree 99 times in one day without incident, the 100th time I must be hit by an acorn? Well, no. If I believed that on this trip under the tree, I would certainly be hit by an acorn just because it was my 100th time, that would be what we call magical thinking. Statistics may sometimes seem like magic, and there is something kind of magical about using them to understand the world, but probability is not magic. It's just a calculation based on our observation of the events. On my 100th time walking under the tree, will some mystical wind rise out of the random forest and shake the acorn out of the tree onto my head in accordance with that 1 out of 100 probability? No. Probability is a calculation based on observation of past events. It is not a rule or magic or a force of any kind. We can use it to estimate how many people will get hit with acorns on their way to the picnic tomorrow, but it's just an estimate. No matter how many times I walk under the tree, the calculation doesn't change. Probability is always the number of times an outcome occurs, divided by the total number of events. Maybe 5 people will get hit with acorns tomorrow, and we'll need to adjust our calculations accordingly. We could have a lucky day where 300 friends walk under the tree and no one gets hit by an acorn. Or I could have an unlucky day. I could walk under the tree once and get hit on the head with an acorn. The probability of that happening is 1 out of 100, meaning it's not very likely, but it definitely could happen. After all, we got our 1 out of 100 estimate because it happened to some of our friends. This is actually another way that gamblers often think, and in this case, they're not wrong. For example, if you play the lottery, you know that your chances of winning are tiny. I mean, absolutely minuscule. However, people do win sometimes, right? Lottery players reason, the chances of me winning are very small, but I could win. After all, someone will win eventually. Yes, though again, the chances of it being you are, well, they're not much better than the chances of someone like me, who has never bought a lottery ticket, winning, that is to say, 0. Anyway, back to Ms. Cherry. Her theoretical probability of winning is still 1 out of 5 each time, no matter how many times she rolls the dice. Although if she were to roll 1,000 times and still not roll 7 or 11 or more, we would definitely call that bad luck. And another example. Say you've always dreamed of scuba diving. You've heard that about 1 in 35,000 people who scuba dive die due to scuba diving related events each year. That's almost 3 times the rate of people who die while skydiving. Seems a little scary, right? But it also means that you still have only a 0.00003% chance of dying, and that is really low. You really want to scuba dive, so you decide it's worth the small risk. So you go through a scuba training, you learn all the basics and the safety measures. After a while, you get your scuba license, and you're swimming around underwater, looking at fish and shipwrecks and all kinds of neat stuff. Now, you've been diving for years, and it's time for your 35,000th dive. Knowing that 1 in 35,000 scuba divers die every year, should you be nervous? If you've been following along, I hope you said no. Your probability is still the same, 1 in 35,000, or 0.00003%. Very good. You learned from Ms. Cherry's mistake. And that's right. The probability still is the same. The number of deaths divided by the total number of dives doesn't change. There's one more piece to this, however, that I'd like to add before we leave the random forest for today. Probability is a pretty simple calculation. As we've said, the number of occurrences of a certain outcome divided by the total number of events. However, real life has a lot of complexity. There are many factors that affect whether a certain outcome will occur or not. Knowing these factors may make our predictions of the outcome more accurate, but they also complicate our understanding. Let's say that last year in the random forest, there were 30 days with thunderstorms. That means that the probability of a thunderstorm on any given day is 30 divided by 365, or roughly 1 in 12. So that gives us about a 1 in 12, or 8% chance of a thunderstorm on any given day. But what if the day is in January? Here in the random forest, it gets pretty cold in the winter, and though we might see a storm with a lot of snowfall and high winds, the low temperature makes thunder and lightning very unlikely. In fact, 26 out of those 30 storms last year were between May and September. So probability is useful, but it may not tell us the whole story depending on what outcome we're looking at, what events we're considering, and the variables that we're taking into account. Let's go back to scuba diving. Earlier, you correctly identified that your probability of dying on your 35,000 scuba dive is no more than your first 34,999 times. The number of death outcomes over diving events has not changed, therefore the probability is still the same. However, your actual chance of dying in a scuba-related accident is not the same on your 35,000th dive. It's probably lower. You see, reports of scuba-related deaths show that there's a common factor in a lot of these deaths: lack of experience. People who just started scuba diving might not understand the dangers very well, haven't learned yet how to be safe, might get overconfident, or might make a beginner's mistake. That's why there is such extensive training and licensure required for scuba diving, though these accidents do still happen. So what does that mean for you? Well, now that you're a seasoned scuba diver, the key variable of experience is now on your side. So actually, you're not in more danger on your 35,000th scuba dive, but less. What small risks do you undertake on a regular basis? Do you skydive, eat pufferfish, drive a car, or gamble at a casino? Do you know the probability of various possible outcomes? Let me know in the comments. Until next time, friends.